Investigation 9, deciding which factoring method to use. We have learned 6 different factoring methods at this point, and we need to look at how you decide which one you use. So, to review factoring polynomials, the first thing you do is you look for common factors. And so common factors are what do they all have in common, and see if you can factor it out. So the first method is factoring out the greatest common factor. The second one is if there are 2 terms. So there's different things that happen when you have 2 terms, 3 terms, and 4 terms. So each one of these things, we're looking for different patterns when we have different numbers of factors. So every time you look for the greatest common factor, whether you have 2 terms, 3 terms, or 4 terms, you look for the greatest common factor first. Then, if it is a 2-term polynomial, then it can only be a difference of squares. And remember, a difference of squares is like x squared minus 9, where it's a subtraction, and this is going to turn into x plus 3, and x minus 3. So that's the only thing for a difference of squares. When you have 3 terms, then, you look for the perfect square trinomial, and that, again, is like x squared plus 10x plus 25, where you know that the last term is a perfect square, and the middle term is doubled that perfect square. So times it by 2, and you get that middle term. And so that would be an x plus 5 and an x plus 5, or an x plus 5 squared. If it's not that, or it's not 2 terms and a difference of squares, and you can't factor anything out, then you have to go and look at our regular factoring methods. And the difference between the 2 of them is one has a 1 in front, and the other has some number in front. And so if it has a 1 in front, then you try factoring with the general form, or if it has some number in front, you try factoring with the general form. If it doesn't factor at that point and it's 3 terms, then it's probably prime and can't be factored. And then the pattern 3 is looking for 4 terms, and that can only be factoring by grouping. So either you can group things together and take something out, or you can't. There's no other choice there. So if there's 4 terms, you can only do grouping by factoring. Just like if there's 2 terms, you can only do difference of squares. Just remember that the first thing you should do on every one of these is see if you can factor something out. So if you continue and you've gone through all of these and nothing factors, then it could be prime. In other words, it's not possible to factor it. So here are some examples, and we're going to go down to the bottom and do these examples in a minute, but these are examples of all of the different 6 types of factoring methods that we've done. And you have to remember that they're not as simple as regular numbers factoring, like 30 is 2 times 3 times 5, because when we're done, we get polynomials out of these. In other words, we get binomials when we're done factoring these trinomials, or binomials, or polynomials, as the 4-part one is called. Remember that factorization can be checked through multiplication, and so you should check these when you're done to make sure they're correct, because you should never get any of these wrong if you check them by multiplying them together or using the FOIL method. So we're going to look now at each one of these. It says match each of the following problems with their proper factoring method and then factor them. So I'm going to start with a difference of 2 squares. How do you know something is a difference of 2 squares? It has 2 terms. So which one up here has 2 terms and is a binomial then? Its only possibilities are this one that's first and this one that's last. And is the first one perfect squares? Is x to the 3rd y a perfect square? No, it's not, because it's got a cube in it. Is x squared minus 4 a perfect square? Yes. So x squared minus 4 is a difference of 2 squares. And so that factors into x minus 2 and x plus 2. Again, because the square root of 4 is 2, and it's got to be a plus and a minus because the middle terms cancel out. Factoring out the greatest common factor. Are there any of these problems that have a factor in common? So let's look at each one of them, starting with the first one. Does that one have any factors in common? Yes, it has x's and it has y's in both terms. So we think that one does, so I'm going to leave that star there. Let's look at the next one. Do these next one have any terms in common? In common in all of them? No. There's not x's in all of them. There's not a 2 in all of them, or a 7 or 14. Next one. Is there an x in all of these? No. Is there a 4 or 16 or 64 in all of them? No. Next one. Again, 8 is 2 and 4. 15 is 3 and 5. They don't have all x's in any of them. And the last one. 2, 7, and 3, so there's no number, and they don't have x's in all of them. So the only one that has something that can be factored out is the top one. So that we put the star by. So let's factor that out right now. What can we factor out of that? We can factor out an x, and we can factor out a y. And so when we factor out an x and a y, then we're going to be left with x squared, because the y's cancel there and one of the x's does, plus 2, and the x's cancel and one y cancels, plus 2y. Now again, you should always check, once you factored out, check the inside. Is that a difference of squares? Because it's a binomial and that's the only possible thing it could be. Is it a difference of squares? Well, x squared is a perfect square, but 2y is not. If it would have to be like 4y squared or 16y squared or something else, and so it's not a difference of squares, so we're done. Next one, which one is factoring by grouping? Factoring by grouping is the one that has 4 terms. So which one of them has 4 terms? Only this one does. So we've done this one and we've done this one. So this is the next one. So let's factor that out. I'm going to take and group the... I'm going to rewrite this here first so I can group it. So I'm going to group the first 2 and the last 2. And remember always it has to have a plus sign in between it. And so we're going to factor out an x squared and be left with x plus 7. We're going to factor out a 2, so plus 2 there, and we're going to be left with x plus 7. And so when we do that, we're going to factor the x plus 7s out. There it is, out. And what's left? X squared plus 2. Now, when you're done factoring, you should always check and see if your 2 factors can be factored again. X squared plus 2 is 2 terms. It's not a difference of squares, and so it can't be factored anymore. So there is factoring by grouping. So all we have left is perfect square trinomials and then our regular factoring methods. So which one of these could be a perfect square trinomial? Well, in order to be a perfect square trinomial, the last term has to be a perfect square. And which one is a perfect square? Well, only 64 is a perfect square. So then we're going to factor that into x and x. And it's got to be the same term, so 8 and 8 is 64. And 8x plus 8x is 16, so, and that's a positive, so it's really x plus 8 squared. So we've taken care of that one. Now let's look for our ax squared plus bx plus c versus this one that has a 1x squared in front of it. So let's match these last 2 up then. This one has a 1 in front of it. This one does not. So let's factor that 2x squared plus 7x plus 3. And again, when you're factoring this, you know that the factors of 2 are 2 and 1. Factors of 3 are 3 and 1. So on this one, there's no choices. We have 2 and 1 and 3 and 1. But we just have to decide which order they go in. So 2x and 1x. And how am I going to multiply those together and add them to get a positive 7? So that means these both have to be positive here. And so when I do that, I need to add these, so I'm going to have to probably do 2 times 3 is 6, and 1 times 1 is 1, and 6 plus 1 is 7. So if I'm going to have to do 2 times 3, the 3 has to go over here, the 1 has to go in the other spot, Okay, so we have 2x plus 1 and 1x plus 3. Now quickly check that. 2x times x is 2x squared. 2x times 3 is 6x. And 1x times x is 1x plus 1x is indeed my 7x, and 1 times 3 is 3. So I know that that is correct. All right, last one is an x squared plus 8x plus 15. And this one doesn't have any term in front, so we only know we have to worry about the last term. So this is x and x. It's again positive, so plus and plus, because this is positive. So we know we're going to add them, and they're going to both be positive. So factors of 15 are 15 and 1, and 3 and 5. So 15 and 1 adds up to 16, 3 and 5 adds up to 8, so we know it has to be 3 and 5. And again, the order doesn't matter there. X plus 3 times x plus 5 is the same as x plus 5 times x plus 3. You may want to refer back to this list excuse me, as you go through and do investigation 9. So on your assignment section here, I've left a whole page where you're going to do investigation 9, 1 through 27. So you're going to answer questions about factoring and how you factor.